Now, I'm going to use this vector to project a position somewhere based along that vector. And then once, let's say I have a position here, I project this position into here. And then I say, look for the minimum position on this surface. And it's going to be stick to the surface. Same thing we're doing to the particles. It's always going to be stuck to the closest point on the surface. And that'll give us 2 points that will be sliding along the our current surface. Okay, so let's make that happen. I'm gonna turn this off, and let's do that. That's kind of a, now that we have these two, it's kind of pretty straightforward. So we're going to say that the vector, that v at p, so my position is going to be equal to the minimum position, min pos, on surface on the second input, based on not my current position, but actually let's do this, call this vector throw. We're going to be throwing the position somewhere. It's going to be equal to at position plus the side vector multiplied by, let's say, 0.1 meters for the time being. Okay, it's just going to be, every point is going to be thrown this distance, and then the new position is going to be min pos on throw. So now that we have a new position calculated based on those vectors, we have that new position, and based on that position, look for the closest position on the surface, and that's going to be my P. We can keep these just for the sake of it, but yeah, this is what we want. These are kind of just to help it. So now this will give us new position on these points. Notice that they were here and they're being projected somewhere along the surface. And now if we merge these two, let's I'm going to do another copy to points in another color. And let's change the color to orange. Change the points, and let's merge these. And we should see that we have, for each blue sphere, we have an orange sphere, always sliding along. Okay, and they're all on the surface, and they're perfectly paired. Okay, now, of course, this needs to be a bit more interesting. Right now, they're kind of going in a very parallel position. They keep the same, they all have the same distance, and they always keep the same distance between each other, and they're always kind of on the same relative direction. So let's just make this is the main thing. This could work, but we can make it better. That's pretty much what I'm saying. So now that we have the core of the algorithm we're trying to come up with, we just need to make it better. But this is the hard part. This is working. If this is working, then the rest should be easy. So let's take care of that on the next lesson.